just know how to use the software. But follow up with me later, give me your email address, and I'll connect you with our subject matter expert on trip analytics. Yeah, I made this point earlier to somebody. It's like, I'm not the SME on trip analytics, but we have a really smart dude that can help you out. So Matt?
Yeah, so I think like here would be an example that if you are doing a study area of ARC, like the actual region, yes, I care about the trips that come through the region, but I really don't like, and I want to see everything within Georgia, but I don't want to see down to the TAZ. That doesn't matter to me. I just want to know that they started outside my area, right, and that they were ending up in this broader region. Like, it basically limits your OD matrix, because if you don't, your OD matrix can be like 1,000,000 rows long. Yeah. Right, because you could be looking at every single zip code within the Eastern Seaboard, which you probably don't want to do. That's probably not important for your study. So it's just a way for it, what Rick was saying for speed, to bind that all down and say, it's outside the study area.
It's outside my...
20% of our trips come from outside ARC.
And
okay, got it, that's correct.
And what's kind of cool about that, what's your name? Matt. So what's cool about that, Matt, is you're accomplishing several things by defining a study area to be smaller than the broader scope of all trips that are unbounded. Remember, we've got trips that originate in frickin' Maine and down in Florida and clear out to Texas. The processing time of your query is going to be quicker, but you're still going to get those external geographies, or what was the term again? I only had 4 hours of sleep last night. Those external zones, you're still going to get a summary at every single one of those OD gates. So if you wanted to know how many trips came in on Cobb Parkway Road around my study area, you're going to get a count of those. It's going to be extensive because you got a lot of OD gates around. The broader the geography, the more OD gates you got. Okay, yeah.
Hopefully this is a software-specific question. Is there a way, maybe they might be able to make a way, like as you're picking and you're choosing different filters and so forth, then kind of like an Amazon cart, you can see the dollar amount going higher, like it's going to take a while, just get ready, or to, okay, you can take things off and see, okay, this will be a faster, but I guess it's very data specific,
so what Rob was talking about is, hey, can the UI work in a slightly different way so that it kind of builds upon the query and it gives you kind of an estimate of how how long it's going to take in time, what that might look like. Your experience from a UI perspective today is going to be very different from what it's going to look like in a year. I saw some proof of concepts for the next iteration of trip analytics just yesterday, and they're working on some really, really nice improvements in terms of making it more dashboard-like, a little more friendly in terms of that interaction between, okay, here's my query, and all right, here's what my trips look like, and here's a graph, and the dynamic relationship between the two, and turning things on and off to kind of filter through check marks. And it looks to be very, very promising. So I'm excited for that. And I think what's nice about the CATT Lab and all of our products, we've been doing this for 23 years. That's when we were founded, 23 years ago. All we do is take input from you guys. So Matt can attest to this. Being a part of the Eastern Transportation Coalition, if you've got feedback on things to improve our products, the UI, maybe your experience with it, just send support@ritis.org an email, and we literally take all of that input into consideration for the next iteration of our software. All right, so we only have hour and 45 minutes? 3:30? Do we go till 3:30? So 2 hours. 2 hours and 15 minutes. So what I want to do this afternoon is so we're switching over to Matt's point. We're switching over to another suite of tools within the broader RITIS platform called Probe Data Analytics. Probe Data Analytics has a boatload of tools. We're going to, this follow-along exercise that I put together for us, it's going to allow us to answer some basic performance measure questions using a couple of the tools. Not all of them, just a couple of them, because there's too many. But what I want to do is walk you through the data that goes into the archive, and Probe Data Analytics allows you to query, which is different from the waypoint data that we used earlier this morning. I want to talk about probe speed data. Then I want to talk about the tools and generally walk you through some of the different performance measures and data visualizations that those tools create, so that you have at least a broad overview and understanding of, oh yeah, I want to look at congestion patterns as a result of this incident around, not just on I-75, but around I-75. What did the speeds look like over the course of the day? Oh, I want to run a trend map. Or, oh, if I want a linear roadway diagram heat map of speeds or congestion along this corridor, oh, that's going to be a congestion scan. Oh, I want to determine, I'm doing some planning work, and I want to determine and validate the priorities for improvements in my MPO or in my region are aligned with the most jacked up corridors in the area. Oh, that's the bottleneck ranking report. So there's all these different tools that give you, they're analyzing the same underlying probe speed data, but the data visualization is slightly different. Some of the performance metrics are going to be different, and that's what I hope to cover within 45 minutes to an hour. And then we're going to walk through how to use Probe Data Analytics. How do you set up a query, and the different nuances and some best practices in setting that up. All right, important. Take a snapshot of this. You have the deck. Remember this slide, though. Matt made this point. Your probe speed data provider is a company called Here Technologies. You have two different underlying road segment databases that roadway speeds are mapped to. And I'll explain this in a little bit more detail shortly. But probe speed data is still derived from waypoints, but it gets mapped to segments. It gets averaged out. It's an average. It's harmonic average. It's kind of, I think for INRIX, it's even though the speed data is coming in every minute, it's a rolling 3 minutes for INRIX. I don't know how Here does it, but there's a lot of cars moving over the roads, right? And the secret sauce to Here and INRIX and TomTom is they're taking all of that speed data and they're doing this rolling average every minute. Or they're taking the last 3 minutes rolling average for a segment and representing that in real time for an individual segment, minute by minute. The underlying road database can be different. There are that they map the speeds to. There's a TMC road network, and then here's network, high definition network. It's called TS, which is short for topological subsegments. If you are doing corridor-based studies and analysis, like signalized corridors, and you need fidelity, performance measure fidelity understanding of what's happening along a corridor, in between signals, or along the corridor, throughout all the signals, you want to make sure you use TS data because it's spatially fine granularity. So you've got very short segments that the speed data is mapped to. TMC segments are generally longer. There's some roads in the state of Georgia that TMC, there's just no probe data for TMCs. Here technologies like INRIX, they start with the National Highway System for TMC segments, which is interstates, state highways, and US routes. And then where appropriate, they'll expand arterials to that TMC network where appropriate, or where a customer is asked, hey, can you include this in the TMC network? Broad-based performance measure analysis, like travel time indexes and broad congestion measures for regions, for states, for all the interstates. It's fine to use TMC segments, but if you want to get into the details of what's happening along a corridor or in and around junctions of an interstate, along arterials, you want to use TS data. Something else to note, and I was having a chat with a young man earlier, we're not talking about at all the real-time situational awareness capabilities of the RITIS platform that's available to you. That being said, we are tapping into your ATMS platform, and you're able to, in our real-time traffic map, see incident data like collisions, obstructions, disabled vehicles, work zones. All of those incidents are mapped and archived in our database as well. That data goes back to May of 2014. Oh, and I didn't mention, like if you want to do comparative analysis for congestion or speed measures, you've got data that goes back for TMCs back to 2018 and for TS data back to 2022. We have GDOT detector data back to March of 2018. There's a whole nother set of detector tools that you can use to query the speed and volume detector data. We're not going to touch that. DMS data, that's back to March of 2018. DMS data gets integrated with some of the PDA report analysis. And then the last data set I want to bring to your attention that you also have available for congestion, speed related performance measure analysis is the NPM RDS data set. National Performance Management Research Data Set. It's a research data set. National Performance Management Research Data Set. This is a program sponsored by the Federal Highway Administration. You could go to their website and download this raw 5-minute by 5-minute speed data for TMC segments for any part of the country. It is multi-state, but it is limited to the National Highway System. So it's only interstates, US routes, and state routes. Again, it's 5-minute segment increments, which is fine for some broad regional studies, performance measure analysis. I think what is a nice differentiator for some traffic engineers and analysts and planners is that this is the only data set that you can run performance measure analysis for passenger vehicles separate from freight truck. The HERE TS data and the HERE TMC data, it aggregates all sources of vehicle type, okay? The NPM RDS data, you can pull out, if you're doing freight-based analysis, you'd be able to do freight-based performance measure analysis using NPM RDS, okay? The NPM RDS data, think it's a rolling 30-day update. So you're not, I think you got I think most recent available data is 30 days old. Here TS data, or here TMC data, you can run analysis, performance measure-based speed or congestion analysis for this morning at 8 a.m. to 10 a.m. if you wanted to. You can't do that with NPM RDS. Okay? So 2 broad sources of data here and the Federal Highways NPM RDS data, but 2 underlying road segment databases that speeds are mapped to. And that's kind of crazy. Oh, hey, here's that poll that I actually was hoping worked in that other slide deck. You guys want to do, let's do this one real quick. So scan the QR code. Let's have some fun with this. What is probe speed data? Do you think you know what probe speed data is? I've got 3 options. Is probe speed data that comes from traffic sensors installed along a roadway? Is it speed data that's derived from onboard GPS devices on vehicles and location-based services from mobile smartphones? Or is it speed data that's derived from the triangulation of 4G, 5G wireless network devices? And our results coming in. Oh, you guys have been listening. I love it. Very good. So 26 respondents. That's a pretty good count. Yes, you are correct. Those of you who answered speed data that's derived from onboard GPS devices on vehicles and LBS from mobile smartphones, that is the correct answer. I have a friend in the audience that works for a company called RITIS. RITIS sources some of its data from mobile smartphone LBS sources. So I don't know who I was talking to about, a lot of insurance companies, they incentivize you to download their app or put a device on your car that measures whether you drive like an idiot like I do or not. Like my insurance rates go way up when I drive like an idiot. This month it's going to be more expensive because you were racing down I-75 or not. Well, insurance companies are using, you run this app on your phone while you're driving. It's collecting telematics information about the behavior of your driving. That gets reported back, and that helps drive your premium on a monthly basis. Goes up or down accordingly. Well, that same underlying data, that telematics data, guess what? It has at XY, Z, XY, and direction and speed. Well, it's just waypoint data. All of that stuff gets mapped to road segments. So it's just another source that increases the penetration rate or the statistical significance, or what was the word that you used, Matt? I've used statistically significant. You use statistically representative. So probe speed data, there's a lot of work that goes into the validation of it. There's many, many more sources of probe speed data that can be mapped to a roadway segment. And that's an example, right? You've got underlying GPS data from cars. You've got location-based services coming from mobile apps. Really, really rich, diverse collection of probe data. And we talked a lot about this already. I don't need to go over that again. So here's that slide that in my first presentation, I said that at midnight I changed it because I was going, wait a minute, that's a slide for probe speed data. I had to change my slide for trip analytics because it's waypoint-based data. So here's probe speed data. Those underlying waypoints, you still have waypoint data that's coming from onboard GPS or location-based services, mobile apps, those waypoints, instead of being mapped to routes and trip segments or trip routes, they're dynamically being averaged, the speed of those waypoints on a segment of road, is being averaged through what's called harmonic mean. So notice that this segment here is green, this segment is blue, this segment is red, this one's orange. The probe speed data provider is taking the real-time speed, they're averaging that speed for all the cars that are passing over that segment every 3 minutes, assigning a speed to that segment of roadway based on its length. So that's the harmonic piece. Harmonic mean, harmonic average. Because it's being harmonically averaged, it's being averaged based upon the length of the underlying roadway segment. So speeds are being mapped to road segments. And what are the two underlying road segment databases? We got TMCs and we got TS, right? Two fundamentally different, they're in the same location, but the TS road segments are smaller in spatial granularity, but the TMC segments are typically larger or longer. But does that make sense? Waypoints map to segments. They're averaged by harmonic mean by length. Big difference. But it's still tremendous amount of data. I don't know why I included that, nor that. Is this? Okay. I included a few extra slides that I knew I wasn't going to need to get into. You can watch the MP4 if you want, but I'm going to skip over those slides, obviously. What we're going to focus on today are just a couple of tools within probe data analytics. PDA is the short kind of abbreviation that I used, and we use collectively within the CATT lab. PDA, probe data analytics, is this collection of tools allow you to query spatially and temporally probe speed data for any road during a certain time and get data-driven insights to what's happening on your roadway to help support your business and answering questions about, whether you're in planning, operations, or maintenance, maybe you're doing research work. The tools help provide insights to reliability, and maybe you need some information to help validate your project prioritization. Maybe you want to do an after-action assessment from an incident that took place. You're a researcher, or maybe you're on the ops side. You had this tremendous incident that closed down all lanes of I-75 southbound for several hours. You want to understand and quantify the cost that the lane closures had on travel through city of Marietta, or travel through the county, or travel through the state. Sometimes you need to quantify in vehicle hours delay or user delay cost in terms of dollars the impact that an event has had. Maybe you want to quantify the impact of a planned event. You guys are just down the road from Atlanta. You've got NFL games. You got Major League Baseball. You've got basketball games. Great way to analyze and quantify the impact that those events have on local congestion. Yes?
Yeah, I used it actually for the FIFA.
FIFA?
But yeah, I saw like the difference before and after like the game and like other days on the same day exactly too. So that was a good analysis.
Yeah, so you guys are hosting?
Yeah, we had the FIFA Club World Cup.
Oh, World Cup.
Year.
Okay.
It'll be the FIFA World Cup also.
Yeah, so if you're doing a planned event before, after action assessment, great set of tools to do, hey, here's what the cost was of congestion before an event. Now, during the event or after, during the event, you could quantify it the same way, compare and contrast percent difference, right? So it could be a natural disaster. You guys have plenty of crazy storms here in Georgia, right? What was the impact of that storm? What roads were most severely impacted and when? And at what location? You could do all sorts of really interesting detailed analysis with the various different tools that are available to you within Probe Data Analytics. This is, if you navigate to this URL, pda.ritis.org, I'm going to encourage you to just go ahead and do that really quickly. This is the quickest way to get to Probe Data Analytics. I mean, you could get to it by going to ritis.org and going to the Data Archive tab, and then from the Data Archive tab, finding the Probe Data Analytics, or whatever we call it, from there. But if you want to get to PDA, just go to pda.ritis.org. Your landing page is not going to look like mine, because I have, again, I'm super user and I've got access to everything. But why I share this slide with you is that every single one of these tools, to perform a query, it's essentially the same. You have to define the spatial parameter and you have to define the temporal parameter to get any results. The big difference between each of these is the output data visualization, or the output information product, or the output report. We're big into data visualization. So each one of these has a different way to render or visualize probe data as a result of the query. And you'll see some of that and some more of that in some of these examples. Oh my God, what did I do? Okay, here's some nice resources. When you download the PDF of my slide deck, you're going to get to this. Page, and I should have put the URL in here. But notice that this graphic that references our best practices handbook, it's actually a hyperlink. You see how I hover over it, and you get that little hyperlink that comes up. If you click that, it opens up a PDF document that's called our Best Practices Handbook. Really, really nice resource for kind of describing data sources, how they're organized, how each of the vendors define reference speed or free flow speed. There's examples in here for each of the tools in terms of how to run a query or perform a query.
Is this the handbook you're showing?
Yeah.
How'd you get to it again?
Just, you gotta, well, one way of doing it is, I mean, oh wow, I'm referencing Oregon's website. That's okay.
Is that not good?
No, that's fine, because that's where it came from.
Okay.
Gotcha.
I already shared it with people.
I didn't realize it was.
But to get to it, Rob,
I saw it. I just clicked on the image and it's.
yeah, click on the image. It's page 47 or slide 47. Yeah.
Also, I'm going to keep you like, this will be my 110th plug for this. You go to GDOT's
Page, there's a hyperlink that says resources that's on the left. If you click there, like, it is a massive list of resources, but on there is the handbook that's there. So I'm sure I'll do like 20 more plugs for that web page, but
So to repeat what Matt said, there's the resource document or website that he's pointed us to a number of times today. It also has a reference link to this handbook. Great resource. Highly encourage you to check it out. It's probably one of the best pieces of documentation that we have, that the CATT Lab has, and we didn't produce it. It's the beauty of the user community. They go off and this is from Oregon DOT put this together, and then we just sanitized it to be generic, so that all of you have it. In fact, you could download the template yourself. I think we provide the PowerPoint, and you can create your own version for GDOT, because at the header of the handbook, there's like data source information. Oregon's an INRIX customer. You guys are here customers, so it might be a cool thing to think about doing. Also, the next page, this is kind of a cool matrix, if you will. Slide 48. This is a link at the bottom of this slide, and the link takes you to this matrix of tools as rows in the matrix and performance measures as columns. So what I mean is, if you were to run, say, a trend map analysis, which is this tool right here, this matrix tells you what types of performance measures that the trend map produces. It produces speed, historic average speed, comparative speed, blah, 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 on and on. Notice performance charts probably gives you the most number of different performance measures. It's probably the oldest tool within the Probe Data Analytics suite. But this is kind of a cool matrix. Like, if you wanted to get travel time index values relative to free flow speed, there's only a handful of tools that generate that. The corridor time comparison, the trend map, the performance chart, performance summaries, and the temporal comparison maps. All right, so check that out. If you're wanting to see where bottlenecks are in real time in your region, this is kind of a weird anomaly tool within the Probe Data Analytics suite, because it's a real-time view of what's going on the roadways, but it's giving you some historic context as well, because you can't calculate a bottleneck in real time if you don't know what the historic conditions were for a road segment. So that's kind of cool thing about Region Explorer. It's one of the first tools in the upper left-hand corner from the PDA landing page. When you check out Region Explorer, you're going to see real-time traffic, NextRad weather radar, real-time speed data, whether it's congestion, comparative speed, real-time incidents and work zones, DMS, CCTVs, no, CCTVs are not overlaid on the Region Explorer. Different ways to render the real-time traffic. But then you see the blue, I'll kind of highlight here in a little bit, that blue line on the map, that's a bottleneck. That's real time. This is where things are the most junked up at the current moment. And then it's the map and the list of bottlenecks on the left are dynamic. So as you zoom in on the map, it shrinks the list of bottlenecks that are on the left, so on and so forth. So that's kind of a neat tool to check out. All right, so from here on out, I'm going to bang through. You have the slide deck. You have the video of my slides. I just want you to see the different data visualizations and output information products and reports that you can generate with the different tools within PDA. But I'm going to be quick because we don't have a lot of time, all right? If you see something that is of interest to you and you want to ask a question, maybe you've used it before and you had a question about using it before that, you didn't have anybody to ask me. Performance charts. Single biggest distinguisher about the performance chart, output data visualization, and results is that the performance chart is the only tool within Probe Data Analytics that gives you statistical variation in speeds. So you're going to get an average speed that's right down the middle, right? Because you're getting a mean speed for wherever you performed your study, for whatever time you performed your study. But the tool also produces a representation of the 25th and 75th percentile range for speed or other performance measure, and the 5th and 95th percentile value. So if I were to, right now I'm looking at percent congestion. I'm looking at basically days in and around Thanksgiving. And if I were to zoom in here, this box and whisker chart, this is representing, let's see, I've got orange and purple. So I'm only looking at 2 days, November 21st, November 27th. The dot represents the mean average. The purple, I'm just going to focus on the purple. Crap. I guess I can't, no, I can't do that. This is the 25th and 75th, and the line, the whisker is the 5th and 95th. I understand that traffic engineers tend to use the 85th percentile value for running some studies. We don't have anything that generates out of the box the 85th percentile value. Our API, like if you wanted to program any of this stuff, create your own dashboard, you could. We've got an API for everything in Probe Data Analytics. In fact, PDA is just a UI front end to a bunch of JavaScript on the back end that's hitting our API library. So what's the difference? What's the difference between 75 and 95? Oh, 85. So if you need that 85th percentile value, this is the only place you're going to get it out of the box. You just, okay, and you'll see if you hover over these values, you're going to get, if you hover over any of these elements, it's going to give you those values for the 5th, 95th, 25th, 75th, and you can perform your own kind of assessment from there. But really, really nice data visualization that goes into, well, what I'm showing you after each tool data visualization, I'm going to show you how the output data visualization might be used in an executive report. All of you need to run this analysis to provide leadership or legislators or the public with insights about what's going on the roadways, right? Well, another resource that you have available to you, and I provide a link somewhere here in my slide deck, a bunch of free report templates. This is a report template that I guess this is somewhere, yeah, this is in Virginia. So Virginia DOT took this report template, they ran some analysis on US 1. In particular, see in the upper right-hand corner, that flashing box? Where did they get that element to this executive report? Oh, they got it from the performance chart. They ran a performance chart analysis, they did a screen capture, and they added it to this report. And then they just added a few elements, like they annotated it with AM peak and PM peak, and they drew a box around some of the, some of these outlying values. There's some really unreliable conditions during PM peak. Same for the northbound, but that's just US 1. Another example, this is an executive report that was just a super simple email executive report that was going out to the governor's office for the state of Maryland. Performance charts. This one was illustrating the impact that the collapse of the Francis Scott Key Bridge in Baltimore had on the local surrounding interstates. In your slide deck, you're going to notice after each tool, I'm going to include the performance measures that are available in the output report. Okay? So for performance charts, those are all the different performance measures that you can derive and use for that data visualization. And then performance summaries, we'll talk about those in a little bit. It's just a summary version of that. Trend maps. The trend maps and temporal comparison maps are my favorite tools because, as I mentioned, I'm a GIS dork from my previous life, my previous career. This is showing you congestion and speed and travel time reliability measures on a map, but animated. So you can actually run some analysis for a day, a week, a month, compare it to several other days, weeks, and months. And what it does is it takes the average data values for whatever the performance measure is that you're looking at. Right now I'm looking at comparative speed in this trend map. And it's gonna chunk it up into temporal increments for the animation. So you can animate it. It's always going to be over 24 hours, but it could be hourly increments, 15-minute increments, 10-minute increments, or minute-by-minute increments. But what's nice, somebody was doing it, let's say we go back to an event-related after-action assessment. We're doing a FIFA World Cup game. What did it look like? Let's say, the stadium is right here on January 11th, and people are coming into the stadium. What did it look like the day before on the left? And what did it look like the day after? This is actually a truck fire. But what you're going to see, the beauty of the trend map, is that over time, you could see the events that are overlaid with the trend map, but it also shows you what's happening on the arterials as a result of the backup. Like, this is miles and miles of bottleneck and a queue. And people are peeling off and they're taking this alternative route, and normally you wouldn't see that, right? So great way to kind of visualize from an after-action perspective the impact that a collision had, a natural disaster, weather event had, or even a planned event. The trend map is also the only tool that lets you take the results and share the results with anyone, regardless of whether or not they have RITIS credentials. So we've got this embed code option. I don't know if you captured that. Right in the upper right-hand corner, there's a little share button. See that guy right there? There's a little share button on the trend map output report. If you click that, it lets you create embed code that you can embed in a website. Like I did this for Ohio DOT. I just took a trend map and I dumped it in their website. Their webmaster was a little pissed at me when I did that, but no, I didn't really. I just did this in cache. It's a fun trick that I like to do, though. Everybody go, how did you do that? But it's just an illustration of how you could take a trend map and embed it. These are performance measures. Here's some examples of a trend map that I embedded into a story map. If you're, again, going back to some ArcGIS implementation and integration options, this is an AM/PM peak, reliability, interactive web map. This is the PM peak. And then I just took the Probe Data Analytics trend map results and I embedded it right into this story map. Fully interactive, animated, performs just like it would within PDA. So another cool example. Here's how VDOT integrated some trend maps into an executive report. There was a result that was put together for a winter storm event that was an absolute mess in 2022. This is January 3rd. I don't believe that's speed. I believe that's congestion relative to the day before and the day after. Really remarkable way to tell the story to leadership, tell the story to the public, what happened as a result of this very, very heavy snowstorm that hammered the Washington, D.C. region, or just south of Washington, D.C. region. Temporal comparison map, similar to a trend map. It's map-based, but what I really like about the temporal comparison map tool is that, I'm going to wait for an opportunity to zoom in here. So there was somebody earlier that talked about excessive speed. I don't know who it was, maybe, yeah. So the temporal comparison map tool is awesome at doing before and after analysis or doing temporal comparison over multiple dates or time frames. And that allows you to do the comparison and see the results on a map. So it'll take day 1, day 2, day 3, or week 1, week 2, week 3, and it will then generate these change maps or delta maps, which you're seeing here, that you can see exactly where the performance measure has gotten better or gotten worse between those respective dates or date ranges that you analyzed. And these are in this video demo, these are delta maps, not the original analysis, but the delta map is showing you in blue where the performance measure, in this case, I think it's comparative speed, has gotten better. But in magenta, the performance has gotten worse between, I think I was doing third quarter of 2020 compared to, I was just doing quarterly analysis, which doesn't make sense. But if you wanted to look at like month over month analysis from a performance perspective, so you want to compare June's congestion and speed measures of 2025 to June of 2024 as compared to June of 2023, this tool does an awesome job at doing that comparative analysis, because not only will it give you kind of like a visual representation of the speed and congestion measures for each of those periods of time, but again, it's doing this spatial overlay, and it's telling you where it's gotten better or where it's gotten worse. And you can play around with the legend to like really highlight where things have gotten worse. This was a snowstorm in Iowa where, you know, I ran temporal comparison the day before relative to the day of. Bottleneck ranking. I'll just say in short, there's a lot going on in the bottleneck ranking report. The primary use for the bottleneck ranking tool is to either, one, determine where the most jacked up corridors in your region are, or validate any assumptions about where you want to make improvements. You know, we all know that project prioritization is driven politically. You also, as professionals, have your own metrics and indices that you use to measure priorities for improvement projects. The bottleneck ranking report does a great job at helping you kind of draw that crosswalk. Oh, okay, does the data tell the same story as what we think we need to do from a project prioritization perspective, or is there a difference? And the bottleneck ranking report is great for that. Lots of cool charts, data visualizations. We see a lot of MPOs integrate bottleneck ranking results into their CMPs. ARC, you guys have your own CMP that you have to generate. Bottleneck ranking reports almost always used in a CMP. Top 10, top 20 bottlenecks, right? And you look at those and, oh yeah, those correlate or correspond to our project prioritization efforts. User delay cost. Cool thing about this tool, it's the only tool, I think, in the industry that can actually calculate the dollar cost impact of congestion. You want to make a compelling story to executive leadership or legislators, guess what? Dollars tell the story. The only way to determine the dollar cost impact of congestion is to use the use delay cost tool. Yes, sir.
So the handbook does a really good job talking about assumptions, but Oregon has their own values, and this might be a question for the class because I've never been able to find a dollar value for the state of Georgia.
That's a good question.
For what, BC ratio?
It requires a cost input for passenger vehicles and commercial.
And for
vehicles
commercial.
for every hour.
For delay?
For delay.
Well, what's the GDOT spreadsheet currently uses, the old values?
Old values is the Texas values. They use Texas.
Every year we update. Okay, so I'm going to repeat the question really quickly. The user delay cost tool is configurable to some degree when you go to set up your query. There's a couple of variables in there that are configurable that establish the cost of the delay per vehicle hour of delay for passenger vehicle and for freight trucks or commercial vehicles. Every year, TTI, the Texas Transportation Institute, they update those values for Federal Highway Administration. We input those into the tool. So we will refresh every year based on TTI's updated values to Federal Highway. That being said, your state should have its own values. And I don't know, Matt, maybe you could speak to this?
I think the default is usually like just go to TTI.
I know that the Office of Planning, to your point, has their own, but they're not, like, if you can't find them, they're not far off. It's like $1 maybe.
So if there's some standard that's being used inside the agency, it's very close to whatever TTI's values are. Included with user delay cost is vehicle hours of delay, vehicle miles traveled. Again, great way to quantify through reports to executives, leadership, legislators. Hey, we want to do this new project. We anticipate it's going to reduce congestion. Well, how much does congestion cost now? Well, congestion is costing let's just say there's an M behind that. It's costing $1.6 million every month. The project's only going to cost $3 million. Oh, and we fully expect that congestion value impact will, get reduced by 50%. Anyway, it's a great way to quantify congestion, validate projects, and tell the story of something that's meaningful to leadership and legislators, and that's dollars. Just drawing that connection between what does congestion cost versus, just looking at charts that tell the story of congestion.
Would there be a way in the future to compare dates and time periods, with this tool?
It does that for you. So you can look at, that's the beauty of probe data analytics. It's all about looking at historical data. And you can look at 1 week relative to another week, another year, another month, or month over month, quarter over quarter, multiple dates. You can get crazy. Generally speaking, there's a limit of 7 date ranges for any single query that you can run. So what's an example?
We work with the trip program. So if we had a trip event happen on July 29th, and it happened at 8 a.m. and it affected traffic until 12 p.m. So would I be able to set up just the average day, what's today, Wednesday, average Tuesday for the last year
Yep.
to that day and that 8 to 12
Yes, sir.
period?
Yeah, so the question is, hey, I had an event that occurred from 8 to 12 yesterday. Yesterday was a Tuesday. If I wanted to look at that event, compare its performance measures, speed, congestion, user delay cost, compared to an average Tuesday for last month, last week, last year, last quarter, yes, you can do that. And we'll see how to do that. Good question. Performance measures. There's, I didn't pause on the congestion. This is a congestion scan. Probably the most popular tool within RITIS because it's, I think generally speaking, it's most widely adopted and accepted way to look at congestion patterns along a corridor. Now, the issue that I have with congestion scan is that you can only look at one corridor, unlike the trend map or the temporal comparison map tool or a bottleneck ranking analysis that you can look at you can look at the whole state if you wanted to. There are linear roadway diagram based data visualizations and probe data analytics like the congestion scan that only let you look at a single corridor. One direction, the other, or both. So this is looking at I-95. Remember that big snow event in 2022 in Northern Virginia? This is looking at the day of the event. January 3rd is here, northbound, southbound. This is the day before, northbound, southbound. It looks like there's a collision here that put some stress on the system between about 11 a.m. and 6 p.m. And you can see the backup, how far the queue was upstream from the incident itself. You can measure that interactively. But this is all red. We're looking at speed, by the way. That's a performance measure. This is a total mess. And then the next day, January 4th, what's going on there? Why do I see gray? No data. You know why? Everyone was stuck on I-95 for this linear diagram represents 50 miles. People were sitting in their car on a frozen interstate in both directions all day into the next day. So there was no movement at all. It was horrific. It's like 48 hours before they were able to get this open. You could see some movement here in the southbound direction and northbound direction during midday to get probably emergency vehicles through here. But otherwise, it was a total disaster. And then the day after, you can see it's returned to normal. But what a great data visualization to tell a story, right, of a weather event like that. All right, a couple examples of congestion scan embedded into executive reports. Another congestion scan. Does anybody notice anything different about this one, though? You guys see a bunch of hash patterns on here? They're black, they're white. About 2 years ago, the CATT lab engineered the ability to take the real-time NextRad weather radar as it's passing over the country. We are overlaying in real time NextRad precipitation and rate of rainfall over every road segment in the country as that weather radar is passing. As it's passing, we're capturing every 2 minutes the fact that it's raining, sleeting, or snowing, and at what rate. Now, when you run a congestion scan, you're able, if you run it for an individual day, It's got to be one day at a time or multiple days. You're only going to see this pattern because, right, weather doesn't exist over multiple days in the same look. Anyway, you have to look at your analysis one day at a time. You can compare multiple days, but it has to be for an individual day. And you get these hatch patterns overlaid on the actual, I'm looking at speed here as my performance measure. It gets overlaid to show the dynamic relationship or context between weather, precipitation, its rate, and congestion. As you hover over your congestion scan, it's going to show you the what the speed is, what the precipitation type is, and a rate. Notice that it becomes snow later in the morning. So that hash pattern changes. You could look at just a certain rate if you wanted to. You can change the configuration of what is viewed on the congestion scan. Super cool. Also notice that you have National Weather Service weather alerts. You've got Waze reported events on here, Waze reported events. It's just a reminder that if you run a trend map or congestion scan for an individual day compared to other days or other months, as long as you're looking at an individual day, you're going to get incident data mapped and overlaid on that congestion scan or trend map. Then if you want, like one of the cool things you could do is you can export. Oh, this is, before I go there, one of the views, performance metrics, is you can look at the weather. So this is like a linear representation of the NextRad weather radar. It's kind of cool. So it's time-based along the roadway corridor, and it shows you precipitation and its rate over time along a really, really neat example. Corridor time comparison. We're running out of time here. Corridor speed bin. Okay. 3:30, 1 hour. Okay. Corridor speed bins. This tool and the data visualization was released probably two and a half years ago. And the one thing that I've heard time and time again that's super valuable about this guy is that it's, we're measuring the average of probe speed data readings for all of these data visualizations up to now. The corridor speed bin tool, what's interesting about it is it takes all observed speed readings for the corridor that you're analyzing and it puts it into bins. So you're able to quantify, in using this data visualization, you're able to quantify of all the probe speed readings for the period analyzed for an individual segment, you're able to quantify how much, from a duration perspective or percentage perspective, duration in terms of hours, how many hours were vehicles going 20 miles per hour, whatever these bins represent, 20 miles per hour to 30, 30 to 50, and 50 to 80. So when you're doing things like you're trying to identify or quantify the impact that speeding countermeasures have had, this is a cool tool to do that. But just to illustrate that, so each one of these horizontal lines, see these black horizontal lines? Those correspond to TMC or TS segments along the entire corridor that I analyzed. So each segment has its own harmonic mean or average of speeds, right? This tool is taking all of the observed speeds that have been harmonically averaged. And it's saying, well, for the period that you analyzed, Rick, November 23rd, every weekday from 12 a.m. to 5 a.m., this is how, these were the observed speed bins. You know, the 40 miles per hour or higher was X percent. Here I'm hovering over this segment, see 12 to 5, Monday through Friday, 90 hours and 16 minutes or 82% were traveling at 50 to 59 miles per hour. The other bins will tell me, you know, of the 100%, what makeup they had. Does that make sense? So you got 100% of all speed readings, and then you could play around with this legend. So if you really wanted to look at, all right, well, the speed on this corridor is 45 miles per hour, and I want to look at the speed readings that are, you know, 10 miles per hour or higher, you move, let's say you move this marker 30 miles per hour over to 50 or 55, whatever, and everything is grouped to be above that value, and everything else is grouped below that value. You can change the colors. You can export this. What are some things? Let me see if I did anything cool with this one. Yeah, this one I played around with the legend to identify excessive speed and quantify excessive speed above 67 miles per hour. I still had 2 hours, 28 minutes for that segment of the corridor. And then, I took that excessive speed from that corridor time comparison, and then I mapped it to I-35, I-45 in Texas to show where there are real problems, right? So I just took the results of my corridor speed bin tool. I moved that legend to highlight excessive speed. You know, let's say the corridor is 75 miles per hour. Anything over 85 is excessive. That's where I want to highlight maybe enforcement or countermeasures or whatever. And I just mapped it. Rob.
Okay. Well, basically you just said, so it's kind of like, say, we all probably know areas that are straight stretches of road, signals that people like to speed on. But how did this, and I'm probably asking, ITSGA July, check out the website, but is there any connection with accident, crash data? Or we just have to make our own connections with that?
Everything's related, and that's kind of there is relationship, right? There are contributing factors to congestion, right? And Rob, you couldn't have asked the question at a better time, because the next tool is the causes of congestion tool. You were reading my slide deck ahead of time.
No, I wasn't.
So causes of congestion, another tool in your toolbox, allows you to kind of quantify, okay, we know there's congestion on the road, right? Everywhere. But what are the contributing factors? You know, is it weather related? Is it collisions? Is it work zones? Is it a combination of factors? What are some of the work zone, weather, recurrent? So the causes of congestion tool allows you to calculate for a corridor or multiple roads what the contributing factors are. And it generates this pretty slick little graphic that breaks down, okay, for the roads that were analyzed, that, you know, of the congestion that occurred, 20% of it was due to incidents. Oh, signals was the other one. 13% was due to signals. Maybe it's poor timing. Maybe, you know, if you got 13% on that corridor that's causing congestion, that might be something to investigate. You know, do we need to dig into this corridor a little bit further? Because it's pretty, is it average? I don't know, but it might be a higher value than not. Work zones, weather, and then as you see here, we got combinations of factors, and it breaks it all out. Each one of these elements is expandable. So you'll get, as you click on each one, you'll get vehicle hours delay, the dollar cost impact, each one of these multiple factors, and it all adds up together. Yes, ma'am?
How does it differentiate between signals and recurrent? Is signals within a certain distance of a signal?
Yeah, so there is a workflow that goes into the calculation. So you start with understanding where there's congestion, right? And the first line of reasoning is, okay, is it, does some spatial analysis, is there anything, was there an incident, was there a work zone, goes through those decision trees. If it doesn't meet any of those criteria, wasn't related to any of those, then there's still congestion. Do we see historic congestion at that particular location? Then that becomes, it becomes a recurrent sort of indicator, because historically speaking, for that time of day, that day of the week, for that corridor, it has congestion. So it becomes classified as recurrent if none of the other factors are met. Does that make sense?
Yeah, it's just a lot of our corridors, I would say a lot of the recurrent congestion is at signals, so I wondered how it differentiated.
Yeah, it's only if it didn't meet the condition, the other condition first, which is signal related and historically the same. Like if it wasn't signals historically, then then it's recurrent. So there is some logic to that. Cause of congestion, follow along. Okay, I think we're ready. Break. Let's take a stretch. Come back at 2:30 though, and then we'll get into the follow-on exercise. A quick resource for you, slide 85 of this deck points to a number of online resources that are available to you. The tool catalog, our tutorials. This one's super important. I encourage you to go check out our reports really quickly. I'm gonna just take you over there, get you oriented. The reports that we provide on this website are curated by subject matter experts like yourselves. We've got planners and operators and maintenance folks, like for work zones. All of these subject matter experts on the different sort of lines of business within a transportation agency have worked with us over the years to generate these report templates. And these report templates are organized on this page by sort of the typical type of report that you would need to generate if you were doing a corridor performance report or work zone report or maybe a holiday forecast. Holiday travel forecast, top 10 bottlenecks. What are these reports, Rick? What are you talking about reports? Well, let's jump into the work zone. And notice when you click on that link, it takes you to a new page. It's organized by overview, tools used in this report, blah, 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 blah. Each one of these links is a link to a report template. So let's open this first one. And what is this? This is a PowerPoint, and that's all it is. What we've done is we've done all of this cool configuration within PowerPoint that then allows you to just run your probe data analytics reports, and you dump the metrics into this PowerPoint template. so you could download these PowerPoint files, and then you run your analysis, say these are performance summary analyses down here. You just take the results and you could dump it into these templates. So there's no programming involved. It's all standardized. Everybody has PowerPoint, right? Know how to use it, know how to kind of annotate and draw elements. So it's take probe data analytics, run your analysis, and then integrate the results into these really beautiful, well-designed, well-curated report templates from the user community. Matt.
Can you go back to that page, the landing page for this real quick?
One. So would you mind scrolling down just a little
For
bit?
work zone?
Yeah, just scroll down. Keep going. So Rick and his team have also done a fabulous job of like dummy proofing this. So if you have never used RITIS before, or you have an intern that doesn't know anything about planning or traffic engineering, here you go, buddy. Here you go. Right? Like, read this. You like probably the first time you do this, it'll probably take you 2.5, 3 hours to just like walk through each step. Like once you've done it 2 or 3 times, like the report, like Rick was saying, is like you can knock these out in like an hour. It's very simple.
Yeah. I've sometimes used these in an exercise with district engineering offices, and this is basically part of the exercise. We run a bunch of reports, and we create these executive level reports that are used internally. Well, there's some districts down in Florida. A couple of them, after training, they've said, oh yeah, a district engineer has said, all right, Gresham Smith, I want you to generate these on a weekly basis using this report template for me. Because the district engineers love these things. But they're all organized by topic area. Again, well described, well documented, step-by-step process. Like even running the tools, to Matt's point, even how to kind of walk through and set up the tools. One example of taking these report templates and automating it in a sense is from one of your colleagues from ARC, not ARC. Some of you may know UJ. I was on the phone with, every once in a while I run reports to determine like who's doing some good work with probe data analytics or RITIS, because I like to reach out to them, like to have conversations with them, find out how they're using the tools, maybe showcase them in our e-newsletter, maybe have them present during our quarterly RITIS user group meeting that's hosted by the Eastern Transportation Coalition. Well, UJ came up in my reports is running hundreds of congestion scans. And I'm going, well, what the heck is UJ doing with all these congestion scans? Well, UJ has created this website. If you get a chance, I encourage you to take a photo of that URL. Really beautiful, impressive work by UJ. He's taken within the Atlanta region pretty much every corridor within ARC's jurisdictional boundary. He's created this dashboard that lets you interactively select the corridor. Through a map or through a tabular list, and then generate a corridor report. And funny enough, this report dashboard looks a lot like some of our report templates that he's leveraged. And all of this is automated. He's just dumped in these values from analysis that he runs in Probe Data Analytics, including performance charts. URL is here again. He's got performance charts in here, corridor or congestion scans. He did some causes of congestion analysis. I mean, there's some really wonderful work that he did for every single major corridor within the ARC's jurisdictional borders. Super impressive. So just an example, just one more example of how you take the results of Probe Data Analytics. You could dump them into these, PowerPoint templates, or if you're a smart dude like you, Jay, you can automate it. And so hats off to him for working through that. All right, let's take a look at the follow along exercise for Probe Data Analytics. So if you go back to this this website that I set up for you guys, one of the links is to the RITIS Probe Data Analytics follow along exercise. Open that bad boy up. Now again, hypothetical, I put this exercise together for you guys to do it back at the office. But what I want to do now is kind of walk through how to set up a query first. And then we'll take a look at this scenario, if we have time, look at the results, and kind of maybe talk through some of the kind of group discussion questions that are in here. But Probe Data Analytics, we've walked through a whole assortment of different tools, their data visualizations, what that looks like, the performance measures, performance metrics that come out of each of those tools, and how they might be used for some executive level reports. Anybody remember what I'd said about Probe Data Analytics and these tools? What are the two key kind of parameters in setting up a query in all of these tools? What were the two key parameters? Any of these tools? The spatial and the temporal. Again, I can't iterate that enough. Every one of these, you have to know, you have to set the spatial and the temporal parameters for the query. So let's do one query. Let's set up one query with the trend map, because that's kind of a good one, and that it has the most options in terms of how to define the spatial parameter. There are some tools within Probe Data Analytics. Let me just back up really quickly. Like the corridor speed bin, the congestion scan, the corridor time comparison. They're linear roadway diagram representations. And so you can only select a single corridor in one or two directions. But the trend map, on the other hand, you could say, oh, I want all these roads, and I want to animate congestion for all these roads for the period of time that I'm interested in analyzing. But to get started, what was Matt's comment earlier? He says, oh, you know what, if you're a consultant, you may have access to multiple data sets. When you go into any of these tools, just make sure that you remember to choose the underlying road data set of interest first. Like, do you want TS or TMC? If it's corridor-based analysis, you're going to want TS. If you just want more detailed spatial granularity anyway, you're going to want TS.
Is there any time you would want TMC over TS?
If you're using the NPM RDS data set, maybe. You know, you'll see that that's an option. So if you change it to TMC, then you have the NPM RDS INRIX. Oh, remember I was talking about this NPM RDS data set? The most recent 8 years of federal data is from INRIX. We don't make that obvious, but you have the last 8 years from INRIX, TMC level. 4 years prior to that is here. So in the event that you're going beyond, what is it, 2018, like 2017 and older, you're going to want to use here NPM RDS, but 2018 and on, it's going to be INRIX. Matt.
To add to your comment, Rick, so Mary, your question was, why would I want to use TMC versus TS?
If you were doing like a statewide snapshot, right? Like
Yeah.
the TSs, the way that they are built is it's like if there is a curb break, that is a different segment, right? So like you can get like they get super, super tight in downtown Atlanta.
The spatial granularity is insane.
Which is great from like a traffic operations perspective. When you're trying to do like a macro view,
Yeah.
that becomes way too much. And I can't remember the exact number, but there is a hard limit on number of links that you can analyze. And so if you're trying to do an entire state and you're trying to do TSs, it would get very upset with you.
Yeah. Yeah, so to reiterate restate the question, hey Rick, at what point would you, what's the scenario in which you would use TMC road segments as opposed to TS? Remember I was saying earlier that TS is fine spatial granularity road segments. So great for signalized corridor analysis. You want to really get into the nuts and bolts of how a corridor is performing relative to timing and overall reliability, use TS data. Even in a small geographic area, TS is fine. But the finer the granularity, the longer it's going to take to perform a query. So if you're looking at maybe an MPO region, or you're looking at a state, or you're looking across states, certainly with NPM RDS, you're going to want to use TMC segments because honestly, the TMC segments are going to give you a fine snapshot of performance. All right, in the 45 minutes that is remaining, let's do a query. Notice that when you open up the trend map tool, you've got, you have to define the underlying probe speed data road segment set that you want to use. Generally, TS is going to be preferred unless you're doing big macro. But one of the first things that the tool asks you for in terms of establishing your parameters for your query is what are the spatial parameters? Like what are the roads you're interested in doing your analysis on? All right. You have several ways to define the roads. They all can complement one another, but don't work together. And I'll explain what that means in a little bit. So I can use the road selection, region selection, segment codes, map-based tools, and saved. Each of those I can use independently to add to my road selection set for this trend map. So let's go in to our area. Now I know a road name called Barrett Parkway. You use the road selection tool if you know the road name. So you can type in the road name. It could be the state route number, like Georgia 280. Oh, that's interesting. And when you click on Georgia 280, it's going to grab all the TS segments that correspond to Georgia 280. So you use road name. Standard nomenclature for state routes is GA-. US routes is going to be US-. whatever the US route number is. If you're doing interstates, it's always going to be I dash, whatever the interstate number is. You see how it's giving you a list of results when you enter the name? You've got, oh, Rick, you've got 143 intersections with this grouping that's north and southbound. Oh, you got the toll lanes that are 14 intersections that are north and southbound. You get all of these candidates that contain I-75. I'm going to share with you that this is not a typical geocoding engine or place. This is designed, this query functionality and the spatial parameter setup for your query is designed to optimize the database structure, optimize querying the database structure. So while it may not make sense to you, it makes sense from a database architecture and structure perspective, and it makes it that much quicker. If you're trying to do a database query, just searching on a road name normally, you'd have a heck of a time. Everything's indexed and optimized based upon these spatial parameter options that are set up for you. Now then, if I don't want all of, what was that? If I don't want all of Georgia 280, I just want northbound, I could turn off the southbound segment. You see that as I zoom in here?
Change the color, please.
Not northbound and southbound.
Rick, could you change the color to like orange?
Oh, is it kind of washed out? So because I'm using TS segments, it's very subtle, but it's running along the center line. You see how I turn off and turn on north and south? They're like butted up right next to one another spatially. But let's just say for conversation, demo's sake, I just want to do analysis on northbound Georgia 480 from Georgia 5 or Pearl Street, Georgia 5, up to where it ends, right here at 41. Notice this little option here. Right now I'm looking at the entire segment. Notice if I click the partial radio button, it brings up two drop-down lists. Now what I have observed, general rule of thumb, is that for segments that go north-south orientation, that the drop-down list corresponds to south on the left all the way up to the north. You'll understand what I mean here in a minute. And then east-west oriented roads will be east-west. So if I only want to start from Georgia 5, I don't want to analyze any of this other southern portions of Georgia 280. I'll just come in here and type GA-5, and look what happens. It gets rid of all the other segments south of Georgia 5, but there's a lot of intersecting roads that have Georgia 5. So I'm going to say Georgia 5. I'm going to go to Pearl Street instead, and that gets rid of it there. And then to the north, maybe I wanted to just go to Cobb Parkway, US 41, Georgia 3, Cobb Parkway. Oh, too far. Herein lies the nuances of this method for defining your spatial, using road name selection. With TS data, the intersections are all the same for several of the segments. So you would have to, using this methodology, you would have to come in and remove one segment at a time. Totally painful. But you don't need to do that because you have other methods like, I want to use the map selection tool, and I only want to look at arterials that, get rid of that, are within. Notice when I hit the map tab, it activates a number of tools that allow me to draw a polygon, rectangle, or circle within the map to determine which roads I want to include in my query. So I could come in here and say, oh, I want those arterials that are road class 3. And I want these. Draw a box around there. Oh, maybe not. But I don't want, you can remove road segments using some of these other graphic tools. See how these road segments are magenta in color? They're pink. All that means is that they're in cache on the browser right now so that you can add and remove. And it's not until you are done identifying the roads that you want in your query that, oh wow, all right, that you then click the add segments. Once you've determined those are the roads you want as part of your query, you click add segments if you're using the map tool. The region tool allows you to identify the roads for your query relative to standardized geographies, meaning, oh yeah, I want all the roads within, what do we say, we're in Cobb County that are interstates. So now I've got all the interstates that are within Cobb County that have been added to my query. And then, oh, well, you know what? I actually want the feeders as well. So you add those. Now I continue to add to this list of roads that I'm interested in, my query. Let's say, for instance, these are the roads that you're going to be analyzing all the time. You don't want to go through this exercise of setting up, like figuring out which roads from here to there every single time. You want to save these road segments for querying again and again. And it's Amelia, is that right? So Amelia's got a project that she's working on. Once she figures out how to define the corridor that she wants to analyze over and over again, what Amelia's going to want to do is click this button down at the bottom. It says Save as Segment Set. You come in here and you say, oh, this is Amelia's roads or corridor. There's an option here. Amelia works with the Gresham Smith team, and she's got youngling interns under her wing, and she's going to tell them, open up Probe Data Analytics and go run this report and use Amelia's corridors for your analysis. So she's going to check this checkbox so that when her younglings come in to run a trend map in the future, all they have to do is go to the Saved tab, and voila, there's Amelia's corridor. You just click it once, add it, and all those roads pop up back into the query. So you're ready to roll. Key feature, remember, save your segment set. Did you have a question earlier? No, you're good? Okay. Any questions about that?
So you have your
Good question. So with TMC data, it's the traditional functional classification system, the federal highways. Here in INRIX, they put this classification system together to roughly align with the functional classification system of the federal government. It doesn't necessarily align one-to-one, but it generally does. So one's going to be interstates, two's going to be like junction feeders, toll, and then major arterials, blah, blah, blah. And then 5 is going to be everything from there. Be careful with it, though, because it's not, again, it doesn't align exactly with the FCS. If for some reason, somebody shared with you a bunch of codes or TS codes or TMC codes, notice that next to that Save As Segment Set button, there's a Show Segment IDs. That Show Segment IDs gives you the unique ID for every single road segment, TS road segment, that's in that spatial grouping that you've defined. You can copy all of those, and if somebody gave them to you and said, oh, run some analysis on these codes, you just go to the Segment Codes tab, paste those in there, and add the segments. Now then, for the trend map, doing that isn't a big deal, but Amelia was wanting to do like a corridor speed bin analysis along a corridor. And a corridor speed bin analysis, you definitely want it along a corridor in a linear roadway fashion, but you need it to be in one direction or another. What do I got going? All of these are orange. What does that imply? If I were to run some analysis, that if I were to try to run a congestion scan is going to have north, south, or east, west. There's multiple directions on every single one of these roads. You can't do this with a congestion scan. It's not going to know what to do. You can't do it with a corridor speed bins tool. Those linear roadway diagram data visualizations, congestion scan, corridor speed bin tool, corridor time comparison, they need everything to be in one direction or another, and consequently color-coded accordingly. But just wanted to share with you that that's what the segment codes is for. Now then, any questions about the different methods for defining the spatial parameter of a query? What do we notice about setting up a congestion scan query? Only one option. You can only look up by road name. What do we notice about the corridor time comparison? Oh God, only road name option. Corridor speed bins. How do we set up the spatial parameter there? Oh, only road name. If it's a linear roadway diagram data visualization, you only have the ability to use road names because it has to know, again, which direction it's going. Because when you say I-75, you want to run analysis on I-75, in a corridor speed bin, you got to have one direction or the other. So what you do is you say, oh, okay, I want northbound, and then you come in here and you say I-75 again, add it, and now you have southbound. And now you have, when you go to look at and run that corridor speed bin or congestion scan or corridor time comparison analysis, you're going to get on one side of your linear roadway diagram, you're going to get the northbound, and on the other side, you're going to get the southbound. Does that make sense? We do not have your milepost data in here. That being said, notice I just toggled between a couple of different, the base map. One thing you can do, if you're looking for a specific location, I did not share this with you, but in the upper left-hand corner of the map frame, there's this search button. So maybe anytime I need to find something in a state because I'm not familiar with the state, I start here. I say, okay, well, where is Barrett Parkway? So I'll do a search on Barrett Parkway. This is just a standard search tool. It finds Barrett Parkway. That's not exactly where it should be. Maybe I wanted to look for Kennesaw, Georgia. Okay, I've zoomed in. I still don't think that zoom extent is appropriate, but anyway, Kennesaw, just not, use this tool to kind of refine geographically where you need to begin to set up the spatial parameter, and then you could go from there. But back to your point, Rob, is like, say you wanted to go from exit to exit. That's usually something I like to use. The satellite image, satellite and aerial image, the overlay has the exit numbers. So it's easy to kind of interactively say, oh yeah, I need to go from exit 268 down to exit 265 for my analysis. Okay? It doesn't have mileposts, but you at least have exit numbers.
How do you actually put that in?
Yeah, it's interactive. So you just, what I do is just say, oh, well, I want I-75, and I don't know where, if I know that I need to go from 265, exit 265 to exit 268, I could do it this way and just say 265 and exit 265. Maybe it's not in there. I don't even remember where exit 265 was. Was that in Atlanta? But I could do it this way interactively with the partial option, or I could just zoom in on the map and say, oh, I want to go from, oh yeah, it's exit 224, and that's at the Hudson Bridge exit 224 exit. So I'll come in here and say exit 224. And again, that's more than I need. So I come in here and I can trim things up. And then I'll go, oh yeah, I want my analysis to go to exit 232. So then I can come back over here, 232, and it's not there. So I'll go to 233 and then back it in. So I guess my point is that satellite aerial image is a great kind of visual, provides good visual context to orient yourself as to where the exit numbers are and where these TS or TMC segments may cut off. And they help you kind of narrow down the scope, the spatial scope of the query that you perform. Once you've set up the spatial parameter, then from there it's pretty straightforward setting up the temporal parameter. You could do individual days. Anybody remember a day that had a, I'm going to do something really quick. We're in Atlanta area, and I'm going to do something really quick. Interstates only. Big incident on any of the interstates in and around Atlanta? Any day recently? Anybody think of anything? Every day? Is that what that snicker is about? All right, let's just, we'll look at the 29th, which is yesterday. And yesterday was a Tuesday. This is kind of fun. Notice that you could say, oh, you know what? I want to look at in June. I want to look at June 1st through June 30th. And I only want Tuesdays in June. I have no idea. Oh, there we go. Yeah, so it's class 2. So part of this, kind of the back end logic, the underlying street database that's used for the TS segments is a routing database that here develops. When you route, when you send trucks through their nav system around Atlanta, trucks are only going to take these routes. They are not going to take any of these because it's congested. So it's a routing network is the back-end logic to the way it's structured and organized. That's only just information that I know that I'm sharing with you. It doesn't make any relevance whatsoever to what we do in probe data analytics with it, other than the fact that it's a pain because it doesn't include all the interstates when I just choose what should be functional class 1. Well, it's not functional class 1, it's yeah, yep. And that's largely what that's all about. All right. I'm going to clear all of that, turn these back on, make them magenta so you can see them. All right, so now I'm looking at yesterday compared to every Tuesday in June, and now I'm going to look at let's do something fun. We can do January through June every Tuesday. Now this will take forever to run, but you get the idea, right? You could get super creative with this. Here's the deal. When thinking about the temporal parameter of your query, you need a baseline to look at kind of the off-peak or out-of-ordinary conditions, particularly if you're doing an after-action assessment. You want to make sure that you have a baseline that's a normal condition, or you want to be able to create a pseudo-baseline by looking at an average of every Tuesday, like in this case, or every Tuesday, Wednesday, Thursday, weekday within a month. Think about seasonal variation as well. Summertime, when the kids are out, people are vacationing. That's a seasonal variation between June and August 1st, then January through March. There's also going to be seasonal variation in maybe the winter time due to weather. So always think about the context and baseline analysis that you're running from a temporal perspective, okay? because it will make a difference. If you're running a trend map, I open up an existing trend map, and but again, you have, if I was only looking at a specific day, which I will do right now. Let's go back to just yesterday. I'm going to just do one day. We can do 15-minute increments, but I'm going to run that, see how quickly it returns. In the 15 minutes we have left, I think I've done a pretty good job at helping you know how to set up a query in probe data analytics, right? Spatial parameter, temporal parameter. The biggest difference in setting up the spatial in all of the tools is some of them are expecting a single corridor. The congestion scan, the corridor time comparison, and the corridor speed bin are corridor based, thus their name, okay? Now then, if we look at and jump over to our exercise, I did pre-run some analysis for you guys so that we can answer questions about things like, hey, where and when did the most significant congestion occur on Barrett Parkway and during which week for the period that was analyzed? Where's my congestion scan? This is my resulting congestion scan. I turned off multiple dates. I looked at full weeks in June and just June 25th because I wanted you to see what a single day looks like in the congestion scan. But there are some things that you could really pick out with regard to a congestion scan and anomalies. Again, this is Barrett Parkway, not a huge segment. It's maybe I don't know, 1 mile in length. You see that little 1 mile mark right there? So I don't, you know, it's not a huge, huge corridor that I analyzed, but I'm going to turn off some of these other weeks. Keep on June 3rd and June 10th. Week of June 3rd and June 10th. I'm going to turn these 2 weeks off. Now, I'm looking at comparative speed. Keep in mind, by default, when a congestion scan opens, this is the performance measure, speed. Does speed tell you anything? No, not in the city, not in an urban area. It's always slow. So I always like looking at comparative speed because comparative speed is the speed of an individual TS segment. Notice how many TS segments are in here. The speed of the comparative speed is the speed of the TS segment compared to the historic average speed for that time of the day and that day of the week. Comparative, right? Like, I want to know how it compares relative to historic conditions because I want to see outliers. And here we have outliers. On the week of June 10th through June 12th, Tuesday, Wednesday, Thursday, I averaged out that work zone, for whatever reason, had between the hours of, I guess, 3-ish and 5, maybe 5:30, going northbound, had some pretty severe congestion. My guess is there was some activity with regard to the work zone. You know, the active workers in the work zone during that time, as compared to the week before. Look at the week before. Nothing going on. How cool is this to evaluate how our flagmen did or flag persons did on the period where it was active versus non-active? The same is true the week of June 10th through June 12th, Tuesday, Wednesday, Thursday, southbound. And in the PM peak, the same sort of weird anomaly, and it occurred throughout the entire segment that was analyzed. But PM peak, we had abnormally high comparative speed for that late afternoon. I'm guessing once again because it was an active work zone as compared to normal conditions. Travel time index values. It's always fun to kind of roll through some of these to get a different perspective on the different performance measures. One thing I wanted to point out is that I also ran this analysis for a single day, June 25th. And wow, guess what? What was that hash pattern again? Rain. And that rain, 1/3 of an inch per hour, well, it almost directly correlates to the congestion along the corridor. It doesn't align as closely as I would have liked it to, as well as over here. I think this is something that I need to follow up with my support team on. But clear correlation, obviously, between precipitation rate, and comparative speed. You could have also picked up maybe, oh yeah. Remember that point I made with trend maps and congestion scans and bottleneck ranking reports? If you're looking at an individual day, with exception of if you're looking at an individual day, any incident, whether it's a collision, obstruction, work zone, it's going to get overlaid in that congestion scan. So there's your construction activity. It's reported, it's active, it's an ongoing event as reported by GDOT. All right. So that was kind of, taking a look at most significant congestion, where that occurred. Were there factors other than the work zone? Yeah, we just looked at that. We had rain on that one particular day that contributed. What were some low congestion periods for scheduling maintenance to minimize disruptions? Well, I could go back to looking at a week at a time, and I could say, oh yeah, maybe AM peak between 9 o'clock and whatever, 11. And the southbound direction are more ideal for activating the work zone than other times, because it's generally clearer when looking at the trend of congestion over time. Northbound's just kind of jacked up all the time towards the northernmost segment of that 1 mile stretch or 1.5 mile stretch. There's probably a signal light right here, is my guess, or a junction to the interstate. So it's just recurrent congestion. You're not going to be able to get around that. But the congestion scan's a good tool for kind of looking at anomalies and figuring out perhaps when to optimize active work zone activities. I also ran a performance summary. I didn't spend a lot of time talking about performance summary other than, like a performance chart, it kind of runs along you're doing analysis for a corridor, but it creates just some basic summary statistics for the time period analyzed. In this case, it's a Barrett Parkway work zone. We're looking at the entire month of January. And what I like about the performance summary is, again, it just summarizes very succinctly into northbound and southbound for the period analyzed, key performance measures: speed, travel time index, and then it groups it. It says, you know what, for weekdays, for PM peak, my travel time index was 1.88, and the AM peak was only 1.23. As compared to the southbound, pretty similar conditions, but per the questions that were asked, how did travel time index values compare between AM and PM peak in both directions? Which day of the week, though, has the highest TTI? So this is kind of interesting because you can, if you look at every weekday, you've got some in the afternoon peak. You got Tuesday really kind of stands out as being, fairly higher than all the other days of the week. But when looking at the northbound, it's actually Friday that's the highest travel time index value. So it's just different ways to kind of pull out, understand where you have choke points, what days of the week you have these choke points, maybe modifying schedules in context to operations. All right, we've got 4 minutes left. I am going to, I did talk about the work zone. I already pointed out the work zone performance measure app. We looked at both Barrett Parkway. So if any of you are in ops and maintenance or just curious about work zones, these are great tools to just kind of keep an eye on how things are doing within the work zone itself. And if you know where the work zone is and you really want to dig into it, like we did here, just define the spatial parameter and run the analysis, and you can really drive into the historic conditions in richer detail than what is available out of the box with that work zone profile app there. All right, any questions? I encourage you, please go back and review some of this stuff. I provided the links to the reports here for you to explore on your own. I think everyone's signed in. Thank you for doing that. Mary thanks you. It saved her some hassle. I will put together the PDH certificates for everybody probably next week sometime. So it probably helps, I'm sure it helps to meet those hour requirements for your PE status. So what's next? Let's get the heck out of this warm room. Oh my God.
I think it's warmer up here than it is in the back.
I'm amazed that you guys are awake. It is so warm up here.
I think first, let's just say thanks to Rick. Appreciate your time.
Thank you.
Most important, if you take nothing from what I'm getting ready to say, is that there is a happy hour over at Hamp and Harry's in Marietta Square. ITS Georgia will pay for some or all, I'm not sure. It just depends on how many of you guys show up. But I encourage you guys to go over and hang out with us. Rick will be there if you want to harass him, I'm sure. Rick never turns down a free drink. So most certainly welcome all of you guys to come and join us for that. Here you go. Here's 111th reminder plug for GDOT's homepage. On there are regularly occurring trainings that University of Maryland puts on for RITIS. It has more to do with their real-time tools. But if you go onto that page, and if we want to go,
From the traffic map, generally, or no, is it from the home page? It would be up there, right?
I know how to direct people to the training, if that's your question.
Well, usually a banner is up there for the next one.
But what I would do is I would look up GDOT big data, and then I would go click on the home page, which is working now, and I would say, what's coming up? And I would click on that link that says Analytics, Tools, Resources, and Trainings. And I would scroll on down to this place where it says RITIS Training Registration, and click on that bad boy.
There it is.
And it would take me to this wonderful page that shows me all the upcoming trainings that are free to you. You do not have to pay. They are free to you to join. They are typically the 4th Friday of the month. So again, feel free. There is also a RITIS user group that meets quarterly. That page that I just had shows you how to sign up to attend those meetings. Those are really great for 2 reasons. One is that's where you get to yell at Rick and Michael and say the tool isn't working the way that I want. So that's really great. Number 2 question, here's how I solved it. So we ran through several use cases, but it's a really great way to make those connections. Hear what's going on and see how they worked that problem. I will certainly say I have ripped off and duplicated plenty of other people's ideas. So definitely encourage you on that. And I'd say the last piece of this is we understand that this is a lot. I've been doing this 8 years using these tools myself. I was doing a report for Chuck the other day, and I was like, I'm going to go about doing it this way. And I did it, and I hated it, and I went into another tool, and I hated it, and I did it again for the 3rd time and finally got it the way that I wanted it to. And I don't say that to discourage you. I very much say that to encourage you to just explore, right? It doesn't cost us anything to run like 100 queries. Now, you might drive Rick crazy, but we don't care. He's not going to be here. So just like run them all at the same time. Like when I'm doing these for Chuck or if I'm doing them for someone at GDOT, I'll come in, I'll get my queries together, and then I'll click submit and go grab myself a cup of coffee while they're running. The reason that they take a long time, and I think you're kind of seeing this, is that number 1, it's a lot of data, but number 2 is that it's building all of those outputs simultaneously, meaning that you can switch between speed, comparative speed, travel time index, buffer index, congestion, comparative speed, blah, 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 seamlessly. So that's why that happens. These are like, when you're talking about the size of Georgia, like these data sets get up into like the high gigabyte and terabyte realm. So it is quite large. So that's why it takes a little bit, but just enjoy the time to wake up, read your emails, get a cup of coffee, and keep trying. So with that, thank you again for attending. We really very much appreciate Rick. Very much appreciate you guys.
Thank you guys for being here.
If you guys need anything, of course, go to the homepage, but also reach out to data support at dot.ga.gov or support@ritis.org. There are friendly people on the other side of those email addresses that are eager and happy to help you.
Yep. All right. Thanks.
Thank you all.
There are also leftover salads if you want to grab them.
Leftover salad.